Oh, hey, Cheryl. So, I've been hearing a lot about quantum computing lately. All this talk about its massive potential. But then I also keep seeing this phrase, the quantum computing skills gap, and it sounds kind of serious. What's really going on there? Oh, Audrey, it's absolutely serious. It's a huge bottleneck, really. We're seeing this incredible explosive growth in the quantum computing industry, right? But the advancement, it's just so hampered because there aren't enough skilled professionals. It's truly a people problem, not just like a hardware or an algorithm thing. I mean, we need people with deep interdisciplinary expertise across physics, engineering, math, and of course, computer science. It's like demand is just skyrocketing, but the supply, it's barely trickling in.
Wow, barely trickling in. So, how big is this gap exactly? Like, are we talking a few hundred jobs, or is this like a global issue that could really slow things down?
Oh, it's global, absolutely. I mean, LinkedIn stats show roles with quantum in the title shot up 180% between 2020 and 2024, like from 3,000 jobs to over 8,400. And the Quantum Economic Development Consortium, or QEDC, they predict we'll need 100,000 additional workers in quantum science by 2030. But get this, a McKinsey report from 2022 said there was only one qualified candidate for every 3 quantum jobs. And honestly, less than half of all quantum computing jobs might be filled by 2025 without major changes. It's pretty concerning for the economy too, because this talent shortage is a primary hurdle for turning lab discoveries into real-world innovations. One qualified candidate for every 3 jobs? That's just wild. So, if someone wanted to get into this field, what specific skills are really in demand? Is it all just super high-level physics, or are there different roles? That's a fantastic question, Audrey. It's not just physics, though that's a big part. But the roles are incredibly niche. For example, quantum error correction experts are crucial because quantum computers, they make mistakes easily, right? We're talking expertise in math and physics here. Globally, there are only about 500 qualified individuals, but over 1,200 vacancies exist. Can you believe that? Then there are cryogenic systems engineers, because qubits often need ultra-low temperatures, like 15 millikelvin. That's almost absolute zero. These folks, they merge physics, engineering, and advanced tech. And then, of course, quantum software and algorithm developers for frameworks like QSKID, Cirq, QTIP. Oh, and quantum application specialists are booming, 85% increase since 2022. They focus on practical uses in finance or chemistry, for example. Wow, 15 millikelvin, that's ridiculously cold. So it sounds like universities must be like scrambling to create programs for these super specialized roles, right? Or are they also struggling with this? Yeah, you'd think so, but they're honestly struggling quite a bit. The curriculum lag is real. Traditional educational tracks have really siloed physics, computer science, and engineering, which makes it super hard to develop the kind of multifaceted talent we need. In 2022, only 29 out of 176 university quantum research programs worldwide offered graduate-level degrees in quantum topics. That's like a tiny fraction. And then, many institutions just don't have the state-of-the-art quantum technology labs to give students that crucial hands-on experience. Plus, teaching complex quantum mechanics with all its linear algebra and probability theory, it's incredibly challenging to integrate into existing curricula, especially for students without strong foundational knowledge. It's a huge uphill battle. That definitely sounds like a tough spot for universities. But it can't be all doom and gloom, right? Are there any solutions emerging? Like, how are we going to bridge this gap if traditional education is struggling?
No, totally not all doom and gloom. There are actually some really promising solutions emerging, which is super exciting. Companies, for one, are investing heavily in upskilling and reskilling programs. Like 95% of tech employees in one survey actually said they want quantum computing training. And then we have these quantum boot camps and online certifications, things like MIT X Pro or IBM's Qiskit Developer Certification, Microsoft Azure Quantum Developer Cert. They're gaining huge traction because they offer practical, hands-on programming experience. Plus, professionals from electrical engineering or computer science, they're pivoting into quantum careers, leveraging their existing skills. You know, over half of quantum tech jobs are open to candidates with a bachelor's degree or less, and strong programming skills can actually make you very employable in the field. And it's good to see early exposure programs targeting undergraduates and even high schoolers now, too.
That's fantastic. So it's not just on the educational institutions, it's a broader effort. Are governments and big industries also playing a role in this?
Absolutely, Audrey. Governments worldwide are pouring money into this. The U.S. National Quantum Initiative has earmarked $1.2 billion, and the UK government, they've committed £2.5 billion. Europe's got the $1 billion EU quantum flagship, and they're even launching the European Quantum Skills Academy in 2026 to scale industry-ready talent. And industry partnerships with universities are crucial. IBM, Google, Microsoft, they're all actively partnering, offering internships, developing new degree programs. IBM's even pledged to train 30 million people in new tech fields, including quantum, by 2030 through its quantum learning program. And curricula are evolving, with initiatives like EdQuantum creating visual, hands-on approaches for associate-level education. So yeah, it's a huge collective push, which is really what we need.